Okay, so with the Riemann sums, what we're looking at in Unit 7 is looking at the accumulation of change. We're looking at finding a way to come up with a way of what all of this space under the curve represents. When we talk about the area under a curve, what we really mean is the area between the curve and our x-axis. If our curve, like a couple of them in the homework, dips below the x-axis, then that area that we're finding exists between the curve and the x-axis. So I want you to think back to pre-calc when you measured angles from that x-axis up and down. It's that same kind of conversation. So what we do is we go ahead and because we can't take the area of this non-circular curve, and by the way, everything we call a curve is any kind of line. A linear equation is a curve. It's just a special kind of curve that is a line. So when I say the word curve, it could denote a straight linear segment of the graph or a curvy part. So curve is a generic term for the graph. When I go to do this, I go ahead and I draw a rectangle, and whether I draw that rectangle with this whole, hold on just 1 minute, I'm sorry. Hello? Yes, this isn't a good time. Can I call you back? All right, thank you. Thanks, bye-bye. Sorry, I saw the weird thing on my thing and I was afraid something was wrong with my dad, so I apologize. That was bizarre. Anyway, so when we go to find the area under these curves, what we're looking at is we're going to estimate them by using rectangles. And when we use a rectangle, the width of that rectangle really determines how accurate of a curve we have. So if I make one wide rectangle here, obviously it's going to cover much of my area but miss these parts. If I do two rectangles, then maybe I get a little bit more, or three rectangles or four rectangles, but what we end up doing is talking about how many of those intervals that we're going to go ahead and denote. For this purpose, we'll go ahead and say that the width of our rectangle is going to be equal to 1. When we do that, we mark intervals on our x-axis. And if you have been confused about how to draw the rectangles, go ahead and grab a straight edge from the basket. Draw a rectangle, and I'll get a pen. Draw a vertical line on the interval up to the graph. Now this is just a part of your box, but for the people who are having a hard time with the left and the right and the center Riemann sums, what we want to do is we want to see where does this rectangle intersect the graph. So we can have these little asterisks show where it intersects the graph. If you are drawing a right-hand sum, that means that on your interval, the box you draw touches the graph on the right of the box. And you are to draw a vertical line, a horizontal line from that right touch to the next spot of the interval, and that is going to be the box that you find the area of. So when I look at this next intersection here, and I draw my line out, I can see if I find the area of this box, for both of these, there's a little bit of an area that I missed. But if I have a curve that both increases and decreases, that area ends up a lot of times balancing out, because notice when I do this right-hand sum, I've overestimated beyond the curve. Notice here I've overestimated beyond the curve. Now that my curve is decreasing again, my right-hand sum results in an underestimation. So by finding the area of each of these rectangles, it allows me to estimate the area underneath that curvy shape. So the hint for drawing, if you're struggling with how to draw them, my advice for you is to draw a vertical line on your intervals up to where the graph is, and then mark. Am I talking about the left hand box or the right hand box? So why don't we go ahead and do this one a little differently. Here we have a width. We're going to change this. Width is equal to 1 for our left hand sum. Let's go ahead and make this one a width equal to 1/2. Because as I mark each of my intervals here, I'm going to be able to get a much more accurate representation because I have a smaller width of my rectangle. So go ahead and draw a vertical line representing where each interval intersects your graph. If anybody needs a straight edge, they should be in the baskets, but I just saw the baskets are over on the windowsill. So if anybody wants a straight edge, let me know. By drawing where those vertical lines intersect, here's some straight edges. Where those vertical lines hit the graph. Now, I'm going to have to do a little bit more sketching, but that determines where I'm drawing my boxes. Because if I am now doing a left-hand sum, I'm going to go ahead and mark the left-hand side of each box. Notice I don't mark this one. So when I go to draw that box, this box is a bit of an overestimation. This box is a bit of an overestimation. This box over. This box pretty much dead on. This box pretty much dead on. This box under. This box under. This box under. This much pretty much dead on. This one over. And this one over. So in doing my Riemann sums, whether I do left or right, and whether the function is increasing or decreasing on that interval, lets me know whether my estimate is going to be an underestimate or an overestimate. Now, you are to do 3 graphs with your trip project, a right-hand sum, a left-hand sum, and the last one is a midpoint sum. The midpoint sum is exactly what it sounds like, where you're going to have to find the midpoint of each of our intervals. So if I go back here and I have a width equal to 1, I still want you marking the midpoint of each of our intervals. And I still want you in a light pencil marking where that midpoint of the interval hits the graph. I'm a bit off on this. So your midpoint sums, even though I said I want a width of 1, go ahead and, if you have another color, what I want you to do is mark your intervals on those one space differences. And instead of your boxes attaching on the right, or instead of your boxes touching on the left, your boxes for each interval are going to cut through that midpoint. And notice here, I'm both an under and an over estimate. So your box is going to go through the midpoint. Your box is going to go through your midpoint. And this is obviously our most accurate, because a lot of times on each graph, we have both an over and an over and underestimate. We can see here there's over underestimate. So theoretically, they balance each other out. Theoretically, they balance each other out. Theoretically, they balance each other out. So when you're talking about calculating the area, length times width will be the formula that we use for each of these rectangles. Our width is determined by our interval and how many rectangles we're going to draw. Our height of the rectangle is determined by the output of the function. All right, so do me a favor, talk with your group, jot your thoughts down in here, and we'll check in a couple of minutes. Go. Your interval is always going to be given to you. So here we had an interval of 1 to 5. When I drew 5 rectangles, my n was equal to 5. So if I did 5 minus 0 over 5, the width of one rectangle in each of these, in this case, is 1. If over this same interval, 0 through 5, I asked for 10 rectangles, 5 over 10, the width of each rectangle would obviously be 1/2. Whether I'm talking about a left-hand sum, a right-hand sum, or the midpoint, that's where my rectangle touches my graph. And whether it's an over or an underestimate, that's going to depend on whether the graph is increasing or decreasing. So you can look at each of these graphs. If it's a decreasing graph, my right-hand sum is an underestimate, and my left-hand sum is an overestimate. If it's an increasing graph, it's the opposite. That midpoint balances each one out individually. You are finding the area of each rectangle, and that is going to be your change in x times your f of x, your output value. And then the accumulation is when I add all of those areas up together. If you're a person who's always interested in the units, this is usually my time, and this is some kind of rate where it's some kind of value per time. And that's where we start talking about these time elements canceling out, and that's why we end up with that value. So when we talked about people in the movie theater or hot dogs on the plate or whatever, making sure that we understand that each of these graphs are all rates. So we could think about all of these graphs are rates. They could be like our derivative graphs. All right, so when we look at example 1, we have this graph f of 3 on interval 0 to 4, estimate the area under the curve. So far, we've done it all when we've been given a graph. But what we can understand is we can make a table where we can talk about our input value, and we can talk about the output value from that. And if we know we have an interval of 0 to 4, I know I have 0, and I want 4 subintervals. So 4 minus 0 over 4 is going to be 1, which means that my rectangles are going to go up with each unit as I go. If this had worked out to be 1/2, I would do 1/2, 1.5, 2.5, 3.5 in addition to those integer values. So my input values that I use on my table are going to be determined by how wide I'm making my rectangles. So the easiest thing to do, and I know you all know the cubic function, no big deal, but when we get to a function that maybe you don't know, if you go ahead and graph, put it into your graphing calculator, and then you go to your table of values. You can play with the table set to determine not only where your table starts, but also its increments that it goes up. If you needed to go up by 0.5, you can enter in 0.5 here. When I go back to my tables, of course, 0, 1, 8, 27, and 64. So just so you know what you're looking at, this is your width, and this is your height or your length of your rectangles. Since they want me to use a left-hand sum, I'm going to use the left-hand intervals for each of my rectangles. So my area of rectangle 1 is going to be my width, which is 1, times my height. My area of rectangle 2 is going to be my width, which is 1, times my height. Area of rectangle 3, my width, which is 1, times my height. Area of rectangle 4, my width, which is 1, times my height. I'm not going to do 64 because I'm doing the left-hand sum. If I was using a right-hand sum, I would do this, 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 and not my 0. So when I have my area values, finding their sum, 27 plus 9 sounds like 36 to me, right? So then the total area is equal to 36 units squared. So we're going to start using a summation notation, and I need you to tell me, have you ever seen big sigma before? Yeah? So what Big Sigma means is add them all up from 0 to 4, tells you what your input is, and f of x and change of x are going to be your length and your width, and 0 to 4 are your intervals. From 0 to 4. So we're going to start using Big Sigma to talk about that. And if you're curious what that looks like on the graphing sense, let me come here and change my graph around. And this is that same GeoGebra link that was in your notes before. If my interval is from 0 to 4, there's my A and B, and I want 4 sub-intervals. Notice I have it set up right now for a right-hand sum, and if I slide this P, here would be if I was doing midpoints, and here's where I'm doing a left-hand sum. So you can see this first interval, it looks like you're like, wait, I thought you said 4 rectangles. I only see 3. This rectangle here is this same product where we started off with a 0. So you can see that. I'll make sure that this link is accessible to you, because if you're struggling with how to draw your right hand and left hand rectangles, having this box and being able to see it is a huge help. And notice we get the area under the curve is 36. What would be interesting is if we continue to draw more and more and more rectangles, look at how more accurate our C value becomes. So an estimation of 36, not so great. When we talk about just having 2 boxes, 16, 3 boxes, about 28.5. 4 boxes is 36. You can see the more boxes. Now that you know what we did before with limits and derivatives, are you feeling like we're going to get to something that gives us a formula as n approaches infinity, where we start figuring out the curve? That's what we're going to be doing after spring break. But understanding the size of n and the boxes and how that estimates that curve is super important, so that you have it conceptually. Make sense? All right, so whether you're doing it with the graph, with the graphs and accumulating the area, or a chart, that's actually what you're doing, finding each of those values. So we're going to take a break from the notes now, and we're going to go back and let's talk about your homework. So take a minute and take out your homework from last class. So on the back of this worksheet is multiple answer grids. You only have to fill out one. So whether you use the left or right, it doesn't matter to me. And I'm giving you each a set of task cards, the Riemann sum task cards, and they're all out of order, and I don't care what order you do them in, but it asks you a question, and then it asks you to choose A, B, or C, depending on this graph. So if you want to take out your calculator and graph it, if you want to have that link, it's on Schoology, or if you think you can converse and get to and decide, then that's up to you. So my advice for how we go about and approach this is to go ahead and enter this into the calculator. Go ahead and enter x squared plus 8x plus 12. If you go to the table of values, it's much quicker to graph it if you use their given input-output values. Uh-oh, what's wrong? Oh, minus 8x. There we go. Thanks, Nadia. You can put a Smarty up. That's better. So when I look at 1, I have an output of 5. So go ahead and graph that here. An input of 1 gives me an output of 5. An input of 2 gives me an output of 0. An input of 3 gives me an output -3. An input of 4 gives me an output of -4. An input of 5 gives me an output of -3. 6, 0, and 7, 5. And then go ahead, do your best to graph your quadratic as a lovely symmetric curve. And our interval is from 1 to 7. So if I have my A and B, that's going to be 1, 7. So when I do B minus A divided by, check it out, they want 8 subpartitions. And we can go ahead and simplify that to 3/4. So when we break this up into quarters, half, half, half and half, half, half and half, divide your integer interval into half, and then each of those into halves. That's the fastest way I know to do quarters. Now, if you want to get a pen of another color, or a colored pencil, or anything that suits, we have some colored pencils that you're welcome to come help yourself to. Because, go ahead. What helps me is if I go ahead and I count 3 of the 4, 1, 2, 3, and this interval, I'm going to draw a rectangle, I'm going to draw a line up to where it hits the curve.
Is it the half between the two and then half of that and then half of that?
Yeah, because you're dividing it into fourths. So here, watch this, Anthony, on a grander scale,
Okay.
between 1 and 2, I'm going to divide it in half, and then each of those in half again. That gives me 1, 2, 3, 4.
Yeah, okay.
So then what I'm going to do is I'm going to count out 3. So 1, 2, 3, and then this is where my first interval is going to be. So when I count out 3, 1/4 puts me at 2. 2, 3, I'm at 2.5. And now notice I'm going to draw down to where my graph is. Because remember, we're measuring the area under the curve, but if the curve is negative, it's that space between the curve and the axis. So now I'm going to count out 3 more. 1, 2, 3. And here is my vertical line. 1, 2, 3. Here is my vertical line. 1, 2, 3. Here's my vertical line. 1, 2, 3. Here is my vertical line. 1, 2, 3. Just after 6, at 6.25 is my vertical line. And it works out evenly so that 7 goes up to the graph. Oh, and by the way, 1 goes up to the graph also. So when we're talking about graphing the accumulation of change, it makes sense that this is going to be negative for us. And it makes sense that these are going to be positive values. Now it's time to go look at whether they said left or right hand. So with the left hand sum, I'm going to mark my left hand, and there's the box that I draw. I'm going to mark my left hand, and there's the box that I draw. I'm going to mark my left hand, there's my box. 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 Mark my left hand, and there's my box. Mark my left hand, and here's my box. So this part of my line is not going to be a part of the calculation. Check in with your group mates and see how they're doing. Yeah.
When I go to the table, it only gives me 3, up to 3.
So if we go to table set. Can I clear it?
Yeah.
So if I go to y is equal to, and we enter x squared minus 8x is 12.
Oh, perfect. Thank
I have
you.
no idea what story it is.
Yeah, I don't know what
Okay. So then if I wanted to calculate the area, my conversation would be this width, which is 3/4, times each of these output functions and the output functions that are on the left-hand side. So 3/4 times 5, 3/4 times 1, 3/4 times -1, 3/4 times -3, 3/4 times -4, 3/4 times -4, 3/4 times, what is that, -1 or 2? -1, and then 3/4 times 1. So that's what we are talking about. Pete, I'd love to give you a copy of whatever we're working on, but I walked around the room with them and I can't find them. Does anybody know where all my copies are? I'm not kidding. Seriously. Does anybody know where my copies are? Like I have in my hand.
Do you leave like the copier?
No, because I didn't have them when I went to the copier. I passed out, right? I passed out all of the copies of the game. I don't think so. That's the craziest thing. I'll find them eventually. They have the maps of the games on them. But now that Pete's here, I have to find them. Oh, I found them. All right. So this one, with your group mates, enter the equation into the graphing calculator. Go to your table of values to get an accurate graph. They want 10 sub-intervals. So go ahead and draw these pictures on your marker set, go. All right, so this one's interesting because, okay, so we had left hand, right hand. This one's interesting because of this 0, so make sure you understand that. Here we changed it to 9 sub-intervals just to keep us on the integer coordinates, but we still had to draw each of the half marks to find the midpoint. And with me, it gets, if I'm confused about it, I just draw my vertical lines to the graph, and then I tell myself, is that the left, right? If it needs to be the center, I need to add the midpoint graphs of each of those. Keep in mind, this is going to be a positive value, this is going to be a negative value, so the total accumulation of change here might end up being 0 by the time I have the positives and the negatives, depending on the values. All right, let's go back to the back of the notes, because what's on the back of the notes is an example of using a chart for the accumulation of change. And when we look at the chart, we don't have a picture, so we have to imagine these rectangles and our input outputs and go ahead and read. So let's see what it says. It says the function's continuous on the closed interval 0 to 60. That's good. And the values given in the table below. Estimate the total accumulation change of function. Use 5 sub-intervals of equal length. So if I have my A and my B is going to be 0 to 60, and then my N is equal to 5. So 60 minus 0 divided by 5 means that I'm going to go ahead and have my intervals 12 long. So when I go from 0 to 12, here's one interval. And then 12 to 24, 24 to 36, 36 to 48, and 48 to 60, I have my 1, 2, 3, 4, 5 subintervals. So when this says a midpoint approximation, so what we're going to do is look at this value here as my midpoint, right? So between 12 and 24, this is my midpoint. Between 24 and 36, here's my midpoint. Between 36 and 48, that's the output of my midpoint. Between 48 and 60, that's the output of my midpoint. So I'm finding the area of 5 different rectangles. Each of them has a width of 12. And when I go to find my length or my height for my rectangles, if it was a left-hand sum, I'd look to the left. And this is kind of confusing. I want to change this drawing a little bit because this 12 is both the end of this one and the beginning of this one. This 24 is both the end of this rectangle and the beginning of this one. Same with 36. This is the end and the beginning. So if that was confusing to you, how I got those midpoints, maybe that makes it a little easier. If I was doing left-hand sums, I would be doing the lower of all of them, 0, 10, 13, 15, and 13. If I was doing right-hand sums, I would do the upper bound, 10, 13, 15, 13, and 11. Because I'm doing the midpoints, I'm going to multiply by the output of the point that's in the center of my rectangle width. So what I'm looking for here is going to be the sum of all of these values. So what's this? 84, 144, 12 times 14, 196, 168, 144, and 144. Whatever this function represents, whether it's, like I said, hot dogs, people, change, money, whatever. So our intervals are 12 wide. If it's easier for you to see on a number line here and to summarize your graph from 0 to 12 to 24 to 36 to 48 to 60. These are my 5 intervals. 1, 2, 3, 4, 5. Each of them has that midpoint. My output at 6, my output at 18, my output at 30, my output at 42, and my output at 54. So here is where I'm talking about my delta x. This is my change in x. And then my output is where I get those second values. So sometimes if they give it to us in the form of a chart, we need to be able to find our intervals on our input values. And then, like I said, whether we're doing left hand, right hand, or midpoint sums, that's what we do for our total accumulation of change. All right, last example. Find the area under the curve of that from 1 to 2. Use the midpoint approximation with 4 subintervals. It is your choice whether you want to use a graph or whether you want to use a chart. My advice is to get used to using the chart, because if you're looking at it with 4 subintervals, 2 minus 1 divided by 4 means that you're going up by quarter points. So 1, 1.25, did I do that right? 1.5, 1.75 to 2. So that's going to be what you're looking for. Bad news, if you're using a midpoint approximation, you need to know each of these values in between. So instead of going up a quarter, you need to be going up an eighth, because you need to know this value in between each of the midpoints. So definitely use your calculator. 2x minus x squared. And then when you go to your table set, instead of going up 1/2 or a quarter, you have to go up 1/8. So you want your table to go up by 1 divided by 8 or 0.625. Then when you go here, you'll end up with each of your values for those. All right. So while you're working on that, I'm going to pass out your homework and your tests.